day, good morning, good afternoon. Whatever time you find this video, it's just a good and beautiful day. All right, yes. Please be reminded again where I have the notes written down for this chapter, and I have a Telegram platform whereby you can find the notes that are written down for this chapter. If you may find it helpful, you can let me know down in the comment section whether to upload those notes, written notes, on my Telegram platform. And also I will leave the link for the Telegram platform in the description below. Just let me know down in the comment section the easy way for you that will help you to understand. Let's look at the power for today. And it's the last video for work energy and power. So power. We spoke about work done on an object, W net and stuff. But although it's important to know the work done on an object, it's also important to know the rate at which work is done. I said what? It's important to know the rate at which work is done. At which work is done. What do I mean by the rate at which work is done? Yes, you guessed it. I guess you guessed it. That's power. That's power. The rate at which work is done is just the definition for power. I said it's important for you to understand the rate at which work is done, but I was giving you the definition for power. So that's the rate at which work is done. So that rate at which is done, that rate at which work is done is known, let me say here, known as power. Right? That's the really short definition for power. The only one that I know in physics. As short as it is power only. So, even though I defined power in words, but there is a better way to define it, also in symbols. Because we are dealing with the calculations here. So in symbols, how do we go about and define this power? So power, as you can see, power here is the way to represent power. So power is equals to, we spoke about work here, and then we spoke about, these are the key terms. So work and the rate. What did we say about the work? The work is represented by the letter W. So the rate at which work is done. How do we know that this will represent the rate? A rate is time in physics. When we talk about the rate, we are referring to the time in seconds. So this is the equation that we will use to calculate the power. Right. So let me just explain the terms again in order for you to get to to understand, to know these letters. So this one, P, represents power, and measurements are important. So power is measured in watts. Watts, like that. And then we have here a W. What does it represent? W represents work done on an object, but I won't write the full detail for it. I'll just write work done, and then we say we measure work done in joules. I explained this in the previous videos, so it's in joules. So now time, how do we write? What does it represent? It represents time, the rate. So here, how do we measure time? We measure it in seconds. You get me? That's it for this equation here, and the measurements, the letters that represents power, the work done, and the time. So what did we say? We said it is important for us to understand the work done on an object, but it is also important to understand the rate at which work is done. How do we know that work is done at this rate? We have the equation P is equals to W over T, of which this represents power. It's the equation to calculate power. So power is measured in watts, work done in joules, and the time in seconds. You get me? Yeah, that's it for power.